Okay, we're going to look at the ellipse homework. So first it has a little bit of a review on circles. So just a reminder that if we're asked to find the center, first off, I know this is a circle because we don't have any numbers being divided underneath those parentheses, or a number in the front where we'd end up dividing and making it equal to 1. We could divide and make it equal to 1, but you'll notice both numbers then would be 81, and so you know it's going to be a circle that way too. So our center, we know that we are going to be shifting to the right 4 and down 3, which puts us at 4, negative 3. And then our radius is the square root of that 81, so it's going to be 9. Okay, so remember that an ellipse is going to be different from a circle because it's been stretched out in some ways. So when we're asked to find the key features of an ellipse, most of the time we'll be asked to find the center, the vertices, and the foci. So those are the main ones. But then, like, what else? What else have we been trying to find with our ellipses? Well, besides the vertices, we could find the co-vertices, which are really just the endpoints of the minor axis. And so really, I think there's 4. I mean, this is a numbered list here. You could add on maybe like the length of the major axis or something like that. But really, those 4 would be perfect. So for number 3, it wants us to complete the square so that way we can write the equation in standard form, which means our goal is something similar to that. So let's see what happens. Let's first put the x's together so that way they're set up so we could factor out that lead coefficient. Okay, and so then we're looking at just the first 2 terms, and then we're going to factor out that 36. So we'll be left with x squared minus 5x. For the second part, we'll factor out the 100. We'll be left with y squared plus 8y. And we still have that 925 hanging out. So we want to complete the square. So we got to take half of 5. Well, really that's just 2.5. And so we're going to take 2.5 and square it. So 2.5 times 2.5. And we'll get 6.25. So this will be 36 times x squared minus 5x plus 6.25, and then I'll write minus 6.25. And then for the second one, when we go to complete that, we're going to be adding y squared plus 8y plus, well, half of 8 is 4, so 4 and 4 make 8, so 4 times 4 makes 16. So we'll have 16 minus 16, and then I still have the plus 925 equal to 0. So remember, the point in that is so these 3 terms will factor, and they'll factor x minus that 2.5 that we had. And this part right here will factor to y plus 4 squared. Now the negative 625 and the negative 16 are inside that parenthesis being multiplied by, and I dropped it here, I just realized, by 100. So this one gets multiplied by 36. So if I take negative 6.25 and multiply it by 36, it's going to be 225. So we're going to get a negative 225. 36 is still hanging out in the front, but it allowed us to kick out that negative 6.25. Next, we're going to still have that 100 in the front here, but 100 times that negative 16 will be negative 1600, and then we have plus 925 equals 0. So I'm going to combine together the negative 225, negative 1600, and 925. And so if I combine those together, that would be negative 900, if I did that right. So we got 36 times x minus 2.5 squared plus 100 y plus 4 squared minus 900 equals 0. So So I'll add the 900 over to the side because we don't want it equal to 0. We want it to equal to 1. So that's our step in getting there. And then we want to have those fractions so we could be in that nice form. So if I divide right now everything by that 900 to make the 1, we're going to have x minus 2.5 squared over, well, if we divide that, we're going to get 25. 36 goes into 925 times plus, and then this will be y plus 4 squared over 9, because 100 over 900 makes 1/9, so 9 on the bottom equal to 1. So this is in that nice, pretty form. Okay, so if we want to identify those key points, since we don't need to graph, sometimes a sketch is helpful. But let's start with the center. We're going to be moving to the right 2.5 and down 4, so 2.5, negative 4. And then our vertices, those are on the longer, the major axis, so they're going to correspond with that 25, which happens to be under x. So we're going to go left and right, the square root of 25, which is 5. So if we're at 2.5 already, if we go right 5, that will be 7.5. And if we go left 5, that's going to be at negative 2.5, negative 4. And then the co-vertices, those are related to the number 9, which is really square root of 9 is 3. We're going to go up and down because that y, 3. So thinking again from the center, if we go up and down 3, up 3 would put us at negative 1. Down 3 would put us at negative 7. And then the last thing to find is our foci, which, remember, the distance to our foci is going to be the a squared minus b squared. So we're looking at 25 minus 9, which will get us a 16. So c equals 4. Remember that the foci are going to be on the where the major axis is, and so that's where our vertices are. So if you think about it, it's going to affect our x's. So again, looking here, we're going to go left and right 4 from the center. So right 4 would put us from 2.5 to 6.5. And then if we go left 4, that would be at negative 1.5, negative 4. And so really, they should be 1 less than where our vertices were, because the vertices were 5 away, and now the foci are 4 away. So those are our major parts that we're talking about. Okay, for number 4, it's already in the pretty form, so it wants us to identify the features and then graph it. So our center is going to be negative 1, or sorry, positive 1, to the right 1, and then down 2. And I know that we're going to move in the x direction, the square root of 25, which is 5. So I'm going to go plot 1, negative 2 on the graph, and then go left and right 5. And then I'm going to go up and down the square root of 16, which is 4. And I'm going to connect those all together, some sort of stretched out circular shape. So the only thing that I don't have on there is my foci. And let's see, identify all the key features. And I guess I could write the actual coordinates for the vertices and the co-vertices. So remember to find the foci. We're going to subtract our a squared and b squared. So c squared equals 25 minus 16, which equals 9. So c will be a 3. So on our graph, they're on the major axis, which is the x direction. So I'll go 1, 2, 3. So there's a focus, and 1, 2, 3. There's our other focus. So if I need to list the coordinates of that, you can, again, think about your center. And if I went right 3, that would be at 4, negative 2. If I went left 3, that would be at negative 2, negative 2, which should match up what you see on that graph. The vertices, those ones went left and right 5, so we'll be at 6, negative 2, 6, negative 2, and then we'll be at negative 4, negative 2. The co-vertices, that's up and down, so we'll be at 1 from negative 2. We went up 4, that put us at positive 2. And then we went down 4, which would put us at negative 6. All right, for number 5, explain the differences between the two equations and their graphs. Let's see, the difference is this is equal to 1, and that's equal to 9. Well, they're both centered at 0, 0, because there's no numbers being added or subtracted. And really they're equivalent to each other, because if I divide it by 9 on both sides, then I would get my 1. And so really it's saying that a circle is really a special ellipse. Where we're going in all directions, up, down, left, right, really 3. So it's just kind of 2 different ways of writing our equation of a circle. All right, for number 6, it wants us to write an equation. So we have our vertices are at 2, 1. So I'm going to plot the information they're giving me. That helps me make sense of things. Now the vertices are the same distance from the center. So if I want to find out where my center is, this distance, let's see, 4, 5, 6, 7, 8. So really I could just go right in the middle, 4 in both directions there, and that should be my center. So my center here should be at negative 2, 1. So if I'm going to go and write my equation, I know it's like something something squared equal to 1 over some number. So I already know that this will be like x plus 2 and y. Make sure you pay attention to our variables here, y minus 1. Now our foci, it says, are negative 2 minus the square root of 12 and negative 2 plus the square root of 12. So let's think a little bit more about this. We're at negative 2. So it's saying plus the square root of 12. So this distance is going to be square root 12, and then they go this distance. That's also square root 12. So that's where the focus is going to be. So they're telling us the distance to the focus. Well, we know the distance all the way to the vertex. That was already 4. So the whole length here was 4. So I'm going to actually go, and over here, since it's 4, I'll put a 16. So really we want to know how much we're going up and down. Well, the distance to the focus is equal to the bigger distance minus the smaller distance. I know the bigger distance squared is going to be that 16, and b squared is what I want to find. C squared is really looking at that square root of 12 squared, so we're going to have a 12 there. So if I minus 16 minus 16, negative 4 equals negative b squared. Looks like b squared will be equal to a positive 4. And that's really all I'm looking for here. You don't have to square root it because we're going to end up squaring it again anyway. And so that's telling me that my graph is going to go up just 2 spaces and down 2 spaces. And so if I needed a picture, that's what my picture would be. And again, my focus was at square root 12, which is somewhere in there to get us an idea. All right, last one here, explain the difference between these 2 graphs. We have they look exactly the same, except this is squared x and y's. So I know that this is going to be an ellipse, and this guy over here with nothing squared, that's just the equation of a line. Both can be rewritten into things that are more familiar. So if you wanted to, the line, we like to put it in that y equals mx plus b form. And for an ellipse, we like them to be equal to 1. But again, you know that they're both different because of those exponents.